Okay, this video is to help you solve ideal gas law problems. Here's an example. What is the pressure in atmospheres when exerted by a 0.500 mole sample of nitrogen gas in a 10-liter container at 298 Kelvin? The first thing you should do for any word problem is always the same step. You need to identify the information that has been given to you and identify what information is being asked. So I'm going to go ahead and circle the information that was given. So over here, I have 0.5 moles of a sample. So I got my moles. I was also given 10 liters, and I was given 1098 Kelvin. All right. And it says what pressure. So the question is asking me for pressure. All right. So let's go ahead and identify a few things. This variable we know is pressure, P. Moles, we represent moles with the letter N in chemistry, so lowercase n is moles. Over here we have our volume in liters, and over here we have our temperature in Kelvin. So now that I can see I was given 1 mole, 1 volume, 1 temperature, and 1 pressure. It does not say anything about there being a change in conditions here. So notice, it's not like it says the pressure was this and now it's this, or the volume was this and now it's this. We've seen that before, but in these kind of problems for the ideal gas law, you're only going to be given one of each variable. And that's how you know that you're not going to be using any of these formulas that you had in the past. So Boyle's law, Charles' law, the combined gas law, all of those, Henry's law, etc. You're not using these where you have one of each. You have an initial and a final. In this case, you're using the ideal gas law, PV equals nRT. So these are your options. Get familiar with them and be able to identify which one fits the information that was given. All right, so now that I know that I'm using the ideal gas law, let's go ahead and focus on this one. And now I need to isolate for the variable that I'm looking for. Every question is different. This question is asking for pressure. So I'm going to be solving for P. I need to isolate this variable. So I need to bring the volume to the opposite side. And the way that we do that is, of course, by dividing by volume. So it was being multiplied. I just did the opposite, divided. So now I've got my new equation here. So I'm just going to bring that over again. Now we've got the correct version of it. We're going to make it a little bigger. Okay. And then, of course, we took this volume and we just moved it into the denominator here. And now pressure is what we're looking for. All right, very good. Now that I've isolated for the correct variable, now you might have to isolate for different variables in the future. So maybe you have to solve for temperature. You would have to divide N and R to the other side. So it would be P over NR equals T. So whatever you're solving for, please make sure that you isolate for the correct variable. Once you do that, we're ready to just plug in our numbers. So I'm going to go ahead and do that. We're solving for pressure. So we're looking for pressure. We know that the mole is 0.55, so 0.5, and those zeros are significant, so don't forget them. And that's moles, MOL. R is a constant. I hope you guys remember that the ideal gas law constant from the video, from the crash course video, is 0.0821. Now, these numbers vary. In this class, we're going to use this, okay? And the units are always going to be liters ATM over mole Kelvin. Okay, so you just kind of got to memorize that. So now that we have that, I'm just going to bring this number, my constant, over here. Cool. All right. And then my temperature, they gave it to me at 298. So let me go ahead and plug that in, 298. Make this a little bit, give us some more room because it's getting a little squished. All right. All right, temperature was 298. So let me go ahead and just put that in, 298. And my unit was Kelvin. All right, and then all of this is over volume. So divide everything by the 10 liters. Okay, now let's pay attention to units. So over here, moles is in the numerator, moles is in the denominator, cancels. Then over here, Kelvin is in the numerator, Kelvin is in the denominator. Liters is in the numerator, liters is in the denominator. The only thing left is ATM, and that's exactly what I want because atmosphere, ATM, is the unit for pressure. So when everything cancels the way that you wanted it to, that's a good sign that you did this correctly. Now, had you not converted Celsius to Kelvin, Kelvin wouldn't have canceled and you wouldn't have had the correct unit, which that's a sign that your answer is incorrect, okay? All right, now that we've got everything good, all we have to do is go into our calculator and solve. So 0.5 times 0.0821 times 298 divide by 10, and we get 1.22329. Now let's look for sig figs. Here I have 3 sig figs. Here, this 0, is it significant? No, there is not a number greater than 0, so that doesn't count. So this counts and everything up after counts, so that's 3. Okay, 3 sig figs and of course 3 sig figs. So my answer should have 3 sig figs. So 1, 2, 2. Do I round up? No, so it should just be 1, 2, 2. So my pressure is equal to 1.22 ATM. Right, and that is your final answer. That's how you use the ideal gas law. A few things I just want to point out. Please make sure that your unit for pressure is always ATM. It has to be. And the reason is, whatever your units were for this constant, everything else has to have the same units to cancel, okay? So since the constant was in atmospheres, your pressure has to be in atmospheres. Your moles, of course, can only be in moles. Can't be like micromoles or nanomoles. Has to be in moles. Your constant, I already told you, and your temperature has to be in Kelvin, okay? And your volume has to be in, you guessed it, liters, okay? So if you don't have those units, that's the only reason that your answer could end up being wrong, other than maybe doing a calculator error, okay? Hope this helps. By the way, I just did the example from the textbook. So here you can see 1.22 ATM. If you want to take a look at your textbook, this is on page 373 if you want a little bit more information.